My name is Mariano Vázquez. I work in Barcelona Super Computing Center, and I am also the CSO of ELEM Biotech, which is a spinoff from Barcelona Super Computing Center. We are located in Barcelona, Spain. What we do in our company and in BSc is we perform. Our company is a spinoff from the Barcelona Super Computing Center, which is a very large supercomputing center, as you can get by name. What is a supercomputing center? It's a place in which we have a very large computer. It's a large supercomputing facility, one of the largest in Europe. It is a center with about 600 researchers now, and everything is around this very large supercomputer. So everything that we need must run efficiently in this facility. So this large computer is very good for solving complex problems. But, because the more complex the problem, the largest computer you need. But the point is that in order to take the best of this computer, you need a very efficient code, simulation code. So in our case, we develop a code which is called ALIA, A-L-Y-A, ALIA. And ALIA is a code for predicting the behavior of nature. So it is based on mathematical model, and with this mathematical model, we have written this code, and there are plenty of algorithms there in order to predict nature behavior. So I am indeed passionate about this very specific detail. The fact that with our code we can predict nature. It's a way of recreating nature in a computer. And as the code can solve very complex problems, really you feel like you are immersed in the problem that you are solving. What we do, we are focused in our company, we are in ELEM Biotech, the spinoff, we are focused in the vertical of biomedical applications. So our complex universe, the universe that we try to recreate and reproduce, is the human body. And this is something that it is really, to me, is indeed amazing. The startup right now is focusing specifically in cardiovascular research, in cardiovascular applications. I have to say that to me, but my background is a physicist. So as a physicist, I can interpret nature as a given set of equations. With these equations, what we can do is we can model nature, no matter what the problem is, and having kind of an abstraction about the problem. So for me, blood or air are the same set of equations. So I use the same set of equations, the same code for simulating the air around an aircraft, the air that you breathe, and the blood that flows in your veins and arteries. So we work right now on cardiovascular applications, specifically in cardiac resynchronization therapies, in which you have the full heart that is beating. So we model electrophysiology, mechanical contraction, and flow inside the cavities, the chambers of the heart. We work also on the respiratory system, simulating the air that gets into your lungs, and how the particles can be transported inside your body. And also a problem that it is very appealing with us, that we are doing with the Washington University in St. Louis, is about pregnancy. So what we are doing is we simulating obstetrician problems, which are problems that every woman have. So these are the kind of our last projects we are working on. I met Luca Emili, the CEO of Silico Trials, a few years ago, and we had the same passion for the same things in silico medicine. In silico medicine is, to me, is incredible, because it is a way of, as I said before, recreating the body in a computer. So it is a very safe way, yet extremely efficient, of, first of all, understanding bodies in healthy people, and how their bodies work. Secondly, understanding how a disease can change your life and what are the consequences that the disease can bring to you. And thirdly, to study the treatments in order to improve the condition of the diseased people in a very safe yet efficient way. We can study all the things at the same time with treatments of different kinds, with what happened with a person with a pacemaker that is taking a drug for COVID, for instance. This is something that we can do now. And what is really amazing is the potential that we have and the power that we have. And we don't see the roof, as we say. It's something that it is continuously evolving and evolving for better. And it's indeed fantastic. It's a fantastic field for doing research and for creating a company like the one that we have created. Modeling and simulation can be more than a game changer in medicine, I think. It can be the next revolution. We are right now in a revolution that it is based on data analysis. And as one of our customers said once to me in a large medical devices company, data analytics and machine learning is like if you are an oil company, data analytics and machine learning is the oil. So it's there. The oil is there, and you go and get it. It's there. In what you can be more efficient, you can be better, whatever is there. And modeling and simulation is the alternative energy. Is the future. It's something that it is the future, but it has already started. So in this way, as an alternative energy can be a completely game changer, not just of oil industry, but of the life of everyone here. I think that this is the power of modeling and simulation. But the problem, well, it's not a problem, it's a fact. But the fact is that, as already happened in many other technology fields like astronomy, automotive, oil and gas, energy, in all these fields, computer-based modeling and simulation and supercomputer-based modeling and simulation right now belongs to the core businesses or to the core field. The fact is that what we need yet is to increase the confidence of the users in our tools. And this is something that is different than in other businesses, in which to increase the confidence, you perform some validation tests and you show, look, we are having more or less the same results, or within this range. In modeling and simulation in biomedical is different. It's not that. You have to go through a statistical validation. It's more, I think that it is more, the word is not validation, it's more confidence than validation. And this is something that must be, well, as it is a statistic, it's a statistic on all sense, in the sense not just by running many simulations, changing parameters and seeing at what extent this variability can bring you to a solution within the bounds that you want, but it is also statistic in the sense that the larger the quantity of people working with this, the higher the confidence that the users can have. So it is kind of it is like an American expression which tells that if the water goes up, everyone is floating, something like that. So this will be beneficial for everyone. So it is just a matter of bringing confidence to what we do. Aging, I think, is the most challenging issue of healthcare, of the healthcare system completely, because we are more people with more age, and as time passes, there are new diseases that are appearing, and the prevalence completely change. Medical devices must be completely different. Drugs must be completely different. So aging is indeed a very challenging issue that will bring a lot of modifications and new treatments and will really turn things around, and will make things much more complex and much more challenging indeed. I think that this is the most challenging fact that it is happening in the healthcare system, and also and also related to our own business, because these will require more and more. As the problems are larger, then you need more challenging simulations to be performed.